Hello students, welcome back. So yesterday we were doing electrolytic cell. Today we'll be doing the final part of electrochemistry, that is electrochemical cell. So what is electrochemical cell? Electrochemical cell is a cell which converts chemical energy into electrical energy with the help of a spontaneous chemical reaction. If we compare electrochemical cell with electrolytic cell, which we discussed earlier, electrolytic cell uses electrical energy to drive a non-spontaneous reaction, chemical reaction. Here we are using a spontaneous chemical reaction to produce electrical energy. Okay, so let's see what is the driving force of electrochemical cell. Like all cells or all processes in the universe, the driving force is delta G, which is supposed to be negative. Now see, if delta G is negative, less than 0, the cell will work spontaneously. Here delta G is equal to minus of NFE. N is the number of electron transferred while performing the reaction. F is Faraday. These both are positive. If you want delta G to be negative, E has to be positive. So what I am saying is that if you want delta G to be negative, for the cell to work spontaneously, E cell has to be positive. Only then cell will work spontaneously. E cell equal to 0 means cell is dead. We have reached equilibrium. If E cell is less than 0, that means cell is working non-spontaneously. We will not fetch any current from the cell. Let's take one example of electrochemical cell, and this is an example of electrochemical cell which is called Daniell cell. Here what we are doing, we are having two half cells, anode and cathode. Here I am using zinc at the anode and copper at the cathode. I am assuming that this combination will give me a spontaneous chemical reaction. So what actually happens, the moment I connect it, zinc starts oxidizing into zinc ions and electrons are produced. These electrons will go through wire towards the cathode and zinc will start eroding. So soon you will find that zinc converts into zinc ions and electrons are transferred along the wire. When electrons go there, here we have got copper ions. Copper ions will fetch the electrons and will reduce to copper. So you will soon see that we have a reddish brown deposition of copper at the cathode. Remember that at anode we always have oxidation and at cathode we always have reduction. So you can see that we are having a spontaneous chemical reaction, zinc going to zinc ions, copper ions going to copper, a spontaneous chemical reaction, and we are having electrons as well. The flow of electrons is called current. We are producing electricity with the help of spontaneous chemical reaction. So this is an example of electrochemical cell. Now as soon as the cell starts working, it will also stop working, and the reason being, as we have more and more zinc ions, a positive charge will develop here. And as the electrons goes there, we'll have an excess of negative charge. Now this positive charge will not allow the electrons to move up, and this negative charge will not accept the electrons, they will rather repel them. So the current will stop flowing. Now in order to have a continuous working cell, we need a salt bridge. This is salt bridge. What is salt bridge? A bridge which contains an electrolyte. So what is the purpose of salt bridge? So when we have a development of positive charge, the anionic part, say I am having electrolyte called KCl, in it Cl negative will come towards positive part and will neutralize that. K plus will go there and neutralize the negative charge. So the cells will be neutralized and the current starts again. So what is the function of the salt bridge? First of all, it neutralizes the cell, it completes the circuit, and also it stops the formation of liquid junction potential. Remember, if I say that instead of zinc, if we are having say silver here, we are having silver. Can I use KCl in the salt bridge? I cannot use. Why? Because when Cl ions will come here, we know that Ag plus will react with Cl ions to form solid AgCl. And if we have got solid AgCl here, ions will not come into this solid part. Ions are stable only in solution, not in solid. So current will stop flowing. Remember that if I am using KCl here, I cannot use on anode silver, lead and mercury. The reason being, the chlorides of these three elements, they are insoluble. They will give you PPT. The moment you get PPT, now ions cannot form there. Is that clear? Let's move further now. So students, you can ask me, sir, how we will come to know that which one will be anode and which one will be cathode? To understand that, we have to understand a term called cell potential. Now, cell potential are of two types: standard reduction potential, standard oxidation potential. While standard reduction potential means under standard conditions. Now, what are standard conditions? Standard conditions are 25 degrees Celsius temperature, 1 molar solution and 1 atm pressure. Under these conditions, if the cell is working, we'll call the potential of that cell as SRP or SOP, depending on the reaction it is proceeding. Now see, SRP means tendency to accept electrons and SOP means tendency to donate electrons, to oxidize. Now see, here we have a reaction, typical reaction. Ag plus accepts electrons to give you Ag, and the cell potential is 0.80 volt. If we go for SOP, SOP will be to tendency to donate electrons, Ag giving you electrons and getting oxidized itself, and the cell potential will be negative of SRP. So if it is a reduction, the value is X. If it is an oxidation, value will be minus X. So the relationship between SRP and SOP is just value will be same, but sign will be opposite. Now, SRP is tendency to accept electrons. It is an intensive property. What do you mean by intensive property? Any property which is independent of the size of the system. So if we have got say 1 Ag plus accepting electron and giving you Ag, I'll have the E naught as 0.80 volt. But if I have got 2 moles of Ag plus accepting 2 electrons and 2 Ag, in a sense I am multiplying the first equation by 2. I will not be multiplying the E naught value by 2 because it is intensive property. It does not depend on the size of system. Whether this is 10 Ag plus, 15 Ag plus, it will remain 0.80 volt. Is that clear? Now see, how you will choose which will be cathode and which will be anode. If the SRP of an element is higher, it will be cathode. If SRP value is lower, it will be anode. Remember that at cathode always reduction will take place and at anode always oxidation will take place. Now E naught cell is given as SRP higher minus SRP lower, or you can say E naught cell is E naught cathode minus E naught anode. If you are doing this type of calculation, you will always get E naught value as positive. If E naught value is positive, your cell will be working spontaneously because delta G will be negative. Is that clear? So students, many a times NEET has been asking question based on the importance of SRP. So here I am discussing if SRP value is higher, standard reduction potential value is higher, then what can be the consequences? We are going to discuss that. If SRP is higher, tendency to gain electron will be higher. SRP means standard reduction potential, tendency to get reduced, tendency to accept electron. If SRP is higher, tendency to accept electron will also be higher. And if you are accepting electrons, the chances are great that it will be a strong oxidizing agent. What is strong oxidizing agent? Any agent which is going to accept electron will be a strong oxidizing agent. So if SRP is higher, the element or substance we are talking about will be a strong oxidizing agent. Third one, the chances are that it will be a non-metal or a transition metal. How? SRP means tendency to accept electron. If you are accepting electrons, who accept electron? Non-metals or transition metal, important one, because transition metals can accept electron in their vacant d orbitals. Remember that. Next one is tendency to produce hydrogen from acids is lower. That means if SRP is higher, tendency to produce hydrogen from acids will be lower. In fact, the elements which are having SRP more than hydrogen, that is more than 0, will not be producing hydrogen when they will react with acids. Remember that, it is very important point. Metal can be extracted easily from the solution. Now in solution, metals exist in the form of ions. Now if that ion is having higher SRP, it will accept electron and will become metal. Now metal is not the part of solution, it is a solid, it will settle down and it can be easily extracted. If SRP is higher, the element or the compound we're talking about will be lower in the reactivity series, because historically reactivity series is basically based on SOP values. Now higher the SRP, lower will be the SOP value. So if you are higher in the SRP, you are lower in the SOP. Lower in the SOP means you are lower in the reactivity series. Okay. Now let's do some questions based on this chart. Here we have got some SRP values of certain elements and ions. Now see, if I ask you which element will be the strongest oxidizing agent, now you see that to be a strong oxidizing agent, SRP should be higher. So in this table, SRP of Ag plus is higher, so Ag plus will be the strongest oxidizing agent among these. If I ask you which of the following will produce hydrogen when they will react with acids, I told you that if the SRP is higher, tendency to produce hydrogen from acids is lower. In fact, the elements which are above hydrogen in the SRP table will not produce hydrogen. So Ag plus and Cu plus, or you can say Ag and copper, will not produce hydrogen when they will react with the acids. Only zinc and magnesium will produce hydrogen. Now, which of the following ions will be easily extracted in the form of metal from the solution? Now SRP higher, it can be easily extracted. So Ag plus will be easily extracted because Ag plus will accept electron most easily and will become silver. Silver is solid, it is not the part of solution, it can be easily extracted. Okay, now which of the following is the most reactive element in this series? Now if you are higher in the SRP, you are lower in the reactivity series. So higher SRP is basically Ag. So a silver will be the least reactive, while magnesium will be the most reactive. I hope the application of this thing is now clear. Is it clear? So students, let us learn how you will calculate cell potential if the conditions are not standard. When the conditions are standard, we call them SRP or SOP. At non-standard conditions, that means when temperature is not 25 degrees Celsius, concentration is not 1 molar and pressure is also not 1 atm if we are using gases. In that case, we have to use Nernst equation. So here E cell will be equal to E naught cell, standard, plus 0.0591 upon n is the number of electrons transferred, log of reactant concentration to their respective powers and upon product to the respective powers. E cell depends on temperature, concentration and pressure. So this equation is valid at 25 degrees Celsius and at different concentration and pressure. So let's do a question based on that. They have given that we have a cell in which cell potential of reduction potential of copper and zinc is given. The concentration of copper and zinc are also given. They are asking you find the E cell. Now these concentrations are not standard concentration, they are not 1 molar. So we have to use Nernst equation to solve this question. So let us learn that. See, first of all, let us find out these are the two half cells. So let me find out the cell potential. E naught cell will be higher SRP. Higher SRP is for copper minus lower SRP. Okay, so that will be 0.34 minus of 0.76, that will be 1.10 volt. Now this is the E naught cell when the cell is under standard conditions. Is that clear? Now let me write down the reaction. So copper, which is having a higher SRP, will be acting as cathode. It will be acting as anode. I told you that higher SRP means cathode, lower SRP means anode. So let me write down the equation at anode and cathode. So at anode, so equation will be zinc will become zinc ions giving 2 electrons, and at cathode the equation will be copper ions will accept the 2 electrons and become copper. Now the cell reaction will be the cell reaction zinc copper ions giving you zinc ions and copper. Now both zinc and copper, they are solid, so their active mass will be 1. So from Nernst equation, E will be E naught plus 0.0591 upon how many electrons are transferred? 2 electrons are transferred upon 2 log of reactant. So this is useless because the active mass is 1. Solid are useless because their active masses are 1. So we have got copper ions. So concentration of copper ions upon concentration of zinc ions. So solving it further, E can be written as 1.10. The value of E naught is 1.10 plus 0.06. I mean, to make simplify that, can I make it 0.06 upon 2 log of concentration of copper ions, 10 to power of minus 3 upon 10 to power of concentration of zinc ions minus 5. So this will be 1.10 plus 0.03 log of, this will be cancelled up, this will be 10 square. So log of 10 square. You can bring it here, 1.10 plus 2 into 0.03 log of 10. Log of 10 is 1. So this will be 0.06. So answer will be 1.16 volt. So this is how you are going to calculate the cell potential under non-standard conditions by using Nernst equation. Is that clear? Okay students, now let us discuss a standard hydrogen electrode. It is also called in short SHE. It is defined as electrode of hydrogen which contains hydrogen ions and hydrogen gas when temperature is 25 degrees Celsius, concentration is 1 molar and pressure is 1 atm. Concentration of H ions and pressure of hydrogen. In these conditions, we have arbitrarily assumed that E naught cell of SHE will be 0 volt. We have assumed it arbitrarily, there is no logic behind it. Now, by assuming it to be 0, we have to measure the cell potentials of other elements with respect to SHE. Okay, so all the cell potentials are relative to SHE. Now, if we have to measure if we have to measure electrode potential of hydrogen at other conditions except standard one, we have to use Nernst equation. So E will be equal to E naught plus 0.06 upon N log of H ion whole square reactant upon product partial pressure of hydrogen. Okay, whenever we have a gas, we have to mention the pressure, partial pressure of that. Now see, this E naught is always 0. It is always 0 because it is measured in standard conditions which we have assumed 0. This E may or may not be 0. May or may not be 0. If you want E also to be 0, in that case it is only possible if this part is also 0. This part will be 0 only if this fraction is 1, because log of 1 is 0. 0 plus 0 will give you 0. So when this fraction will be 1, when the H ions whole square is equal to partial pressure of hydrogen. Okay, now let's come to cell notation. Now they will give you question based on cell notation. Now understand what is cell notation. Remember that there is a double arrow which is called salt bridge. Anything left to it is called anode, anything right to it is called cathode. At anode, remember, always oxidation will take place, and at cathode always reduction will take place. Rightmost and leftmost part are reserved for conductors, the metal one, and the concentrations are mentioned in brackets. Single arrow designates change in phase. Solid, solution, solution, solid. Is that clear? Now let us solve some questions to make it more clear. So students, understand this thing, the cell notation of hydrogen electrode. Now in hydrogen electrode we use platinum as the conductor, hydrogen gas, and the concentration of H ions. Now these values can be anything. Remember that they can play with the source of the hydrogen ion. So you need not surprise when you see the questions in the examination hall. Say HCl, they will not give you directly H ion concentration, they will give you the source of H ion. So HCl is a source of H ion. So 1 molar H ion, 1 molar HCl will give you 1 molar H ion. Similarly, CH3COOH is nothing but source of H ion. You just see that we have, whenever you will find hydrogen gas over there, the remaining part will be the source of hydrogen ions. Okay. Similarly, H2O also dissociates to give you H ions and OH ions. So H2 is also a source of H ion. This last part will be the source of H ion. 4 years back they asked a question in NEET and it was like that: platinum, hydrogen and H2O at 25 degrees Celsius. They were asking you E cell of this cell. Now, many students were not able to solve this question that year. The reason being, they were just fighting for where is the H ion concentration, what kind of cell this is. I'm telling you, once you see hydrogen gas, this will be the source of H ions. Now, I know that at 25 degrees Celsius, H2O will give me H ions as well as OH ions. Water, though, is a weak electrolyte, will give me H ions and OH ions, and their concentration at 25 degrees Celsius is 10 to power minus 7 molar, 10 to power of minus 7 molar. I am interested in H ion concentration. So now my cell becomes platinum, hydrogen given at 1 atm, and H2O is nothing but source of H ion, and the H ion concentration is actually 10 to power minus 7 molar. Now I can write down the equation for this cell, which is like 2H plus 2 electron giving you H2. Remember that if nothing is given, you have to write down the equation for reduction reaction. Okay, so this is the reaction. So now applying Nernst equation, E will be E naught. E naught for hydrogen is 0 plus 0.06 upon how many electrons? 2 electrons. Log of reactant, what is that? H ion. H ion whole square upon partial pressure of hydrogen. So we can solve it. E will be, E naught is 0. So 0 plus 0.03 log of, so H ion is 10 to power minus 7, that will be 10 to power of minus 14 upon partial pressure of hydrogen is given as 1 atm upon 1. So E will be, on solving it, minus 14 into 0.03 minus of 0.42 volt. So that is how you are going to solve this equation. Now see, understand one more important thing. If they ask you in this question that I'm changing it little bit, I'm making it PATM. Now they are asking you at what pressure of hydrogen this cell will behave like she. When I say the cell will behave like she, I mean to say that now this E should also be 0. This is already 0. I want this to be 0. This is only possible if we have got this thing as 0, and log of something will be 0 only if H square upon partial pressure of hydrogen is 1. This ratio is 1. I know that H ion square, H ion says 10 to the power minus 7. So if you want this to be 0, in that case partial pressure of hydrogen should be equal to H ions whole square. Now H ion says 10 to the power minus 7 whole square will be 10 to the power of minus 14. Now if the partial pressure of hydrogen is 10 to the power minus 14 atm, in that case this ratio becomes 1, overall log becomes 0, and I'll have the value of E to be 0. Is that clear? So students, let's see one more question, and see this. Platinum is given, a gas is given. Whenever you see the gas, the remaining part should be the source of the ion of the gas. So this cell actually should be platinum Cl2 1 atm and nothing but Cl ions, whatever their concentration may be. Okay, we got to calculate that. Okay, now see, let me calculate the concentration of Cl ions. They have given me AgCl, which is saturated, and they have also given me the Ksp values. So I know that for AgCl we'll have Ag plus and Cl ions. If the solubility is S, this will be S also. So Ksp for a salt like AgCl, which is AB category, it will be S square, which is given as 10 to the power of minus 10. So S will be 10 to the power of minus 5 molar. So the concentration of Cl ion is given as 10 to the power minus 5 molar. That I have confirmed now. Now see, let me write down the cell reaction. If nothing is given, you have to write down the reduction reaction. So Cl2 will accept 2 electrons to give you 2 Cl ions. So for this now E will be E naught, which they have given me, plus 0.06 upon how many electrons? 2 electrons, log of reactant partial pressure of Cl2 upon Cl ions whole square, the law of mass action. This is given as 1.36 volt plus 0.03 log of partial pressure of Cl2 1. Cl ion concentration is given as 10 to the power minus 5 molar, square of that 10 to the power of minus 10. This will be 1.36 plus 0.03 log of, take it up, 10 to power of 10. This will be 1.36 plus 0.03 log of 10 to power 10 is 10 into 10. This will be 0.3. So you add it, it will be 1.66 volt. Remember that in these kind of question, see the kind of a cell you are having. We are having a gas electrode, gas and its ion. So this will be the source of the ion of the gas, that is Cl2 will have ion called Cl negative. Now go for the concentration of Cl negative. Is that clear? Okay students, let's see the next question. This question says, how much will the reduction potential change if solution is diluted by 10 times for this reaction? So in solution we will have the concentration of zinc ions. Now see, I'm changing the concentration. So if we change concentration, what will be the effect on the E cell? For that we have to use Nernst equation, and Nernst equation says that E will be E naught plus 0.06 upon, for this cell it will be, N will be 2 log of zinc ion concentration reactant upon product, that will be 1, because this is solid are having active mass of 1. Okay, now see, let me take the initial concentration as 1 molar. So at 1 molar, that is standard conditions, I will have the value of E naught, and after diluting by 10 times the concentration will be like 1 by 10. So I have to calculate E for that kind of concentration. Okay, so E minus E naught will be 0.03 log of zinc ion concentration has now become 1 by 10. I am taking initial concentration as 1 and now it will be 1 by 10. It will be 1 by 10. So now E minus E naught will be equal to 0.03 log of, I can take it up, 10 to power of minus 1, and E minus E naught will be, take it up, minus of 0.03. This negative sign signifies that the reduction potential has decreased by 0.03 volts. By 0.03 volts. Remember that E naught I am taking when the concentration is 1 molar. E I will define when the concentration is 1 by 10. So the change is minus of 0.03 volt. That means the potential will decrease by 0.03 volt. So I can say the change is that cell potential E cell will decrease by 0.03 volt. If the answer was like E minus E naught equal to 0.03 volt, that means E cell has risen, increased by 0.03 volt. Negative sign means that it has decreased by 0.03 volt. Is that okay? Okay students, let's understand a very small concept. Need to ask some simple direct basic questions on this concept. This is about relationship between E naught cell and equilibrium constant. So when we reach equilibrium, E cell becomes 0. Cell is dead at equilibrium. We have discussed that. So Nernst equation will change now to give you E naught is equal to 0.06 upon N log of K equilibrium constant. Now see, we have a question on that. X2 plus giving you, plus 2 electrons giving you X. E naught cell is given as 0.3 volt. Find equilibrium constant. Direct question, simple question. So put it there. So E naught is given as 0.30 volt equal to 0.06. Number of electrons involved 2 log of equilibrium constant. So solve it. This will be 0.03. Cut it up. This will be 10. So log of K equilibrium will be 10. Now we know that the base is always 10 for log. Now take the anti-log. K equilibrium will be 10 to the power of 10. Simple one. So let's do one more question. This question is about a reaction. Aluminum fluoride is being converted to aluminum and fluorine. For this they have given E cell and they're asking delta G. Now I know that delta G is equal to minus of NFE. E they have given. Faraday I know that. N number of electrons involved in this reaction I got to calculate. Now see that in this compound aluminum is present in +3 state. So aluminium is plus 3. It is becoming aluminium over here by accepting 3 electrons to give you aluminium. How many aluminium I want? 2 aluminium. So if I want 2 aluminium, I should multiply this equation by 2. This will become 2Al3 plus, and this will become 6 electrons. So 6 electrons are transferred. Aluminum is accepting 6 electrons and fluoride will be giving 6 electrons. So net electron transfer is 6. So N in this formula is 6. Now put this value. Delta G will be minus of 6, F will be 96500, and E is given as 4.5. Now when you will solve it, you will get your answer in joule. To convert this into kilojoule, divide it by 1000 and you will get the answer in kilojoule. Solve it and you will get minus of 2606 kilojoule. This much of free energy will be involved in this reaction. Okay, but students, I mean, let's discuss batteries. Batteries are more data based kind of thing, so I'll suggest you to go through that and try to do it yourself. There are lesser concepts out there. Batteries are like divided into 2 categories: primary cell and secondary cell. Primary cells are like which need not be recharged. They cannot be recharged, while secondary cells can be recharged. So I'll be discussing the most important of them all, that is called lead storage battery. It is an example of a secondary cell. So see, here we have got anode and cathode. Anode is made up of sponge lead and cathode is made up of a grid, lead grid, in which we put in PbO2. Now see, the reaction which occurs here is that at anode, lead is oxidized to lead sulfate. We are using H2SO4 as electrolyte over here, and the electrons are transferred to PbO2, which accept the electrons and become lead sulfate. So net reaction is that we are having lead sulfate. Remember that when the battery is discharging or supplying current, in that case lead sulfate is formed both at anode as well as cathode. Remember that. Okay, and when you will be charging the battery, the reverse reaction will take place. Lead sulfate will become Pb at anode and PbO2 at cathode. Okay, student, now let us study this fuel cell. So fuel cell is a cell which converts combustion energy directly into electrical energy, and its percentage efficiency is the most among all kind of cell. It is almost 70%. To calculate percentage efficiency, you take delta G, the useful energy, upon total energy given into 100. You will get the efficiency, which is normally around 70%. Okay. Now in fuel cell we use hydrogen as the fuel and oxygen as a oxidant. NaOH or KOH is used as electrolyte. So this reaction takes place basically in basic medium. So this is the reaction at anode. Hydrogen in presence of electrolyte KOH or NaOH will give you water and electrons. Electrons will be accepted by O2 and it will give you OH ions. So net reaction will be twice H2 plus O2 giving you twice H2O. No pollution. It is completely environmental friendly. And ultimately, finally, you are getting water as a byproduct, which you can utilize anywhere you want. Clear?